So when we talk about voting, what we're talking about is representatives. For instance, like the U.S. representatives, there are 435 for the whole United States. It's not the same as voting for the president or the Senate. Senate would be 2 people per state no matter what. And the president, of course, is the whole country with electoral college. So we're not talking about those two. But we are talking about like voting in a town for a board membership type thing. So what we need for this type of calculation is the number of people in the total voting area, depending on if it's a whole United States, just a town, or maybe even a county. We need to know the number in each subdivision. So if we're talking about the United States, the subdivisions would be state. If we're talking about towns, it might be the east side, west side, south side, whatnot. The total number of available seats in the voting area, there are 435 U.S. representatives, and they represent the entire United States. Depending on how many come out of each state is what this whole process is about. So with this information, we need to find things like, one place calls it the Standard Devisor. Now the Standard Devisor is literally just the number of people in a voting area divided by how many seats. So this is equal to number in voting area divided by the number of seats. It's also basically representatives per person. Or I'm sorry, that's backwards. People per representative. That's what you get for being a little sick. Alright, so if we're talking about the United States, there are 318 million people, approximately. And there are 435 seats available for these representatives. So if you divide this, it tells you how many people are represented by one of these representatives. So if you take 318 million, that's 6 zeros after that, 318, divide by 435, and you get, let's see here, 731,034. So each one of the representatives on Capitol Hill represents over 500,000 people. Not very representative. Of course, by the U.S. Constitution, it's supposed to be 30,000 is the answer over here, but it isn't anymore. Alright, so one number we have to calculate is the Standard Devisor. The other one is the standard quota. Now, obviously, I'm not going to use this big answer anymore. We could. We're going to have a hard time coming up with an exact number. Like if one representative represents this many people, then two would represent 1,400,000. You'd have to find a state that was exactly 1,400,000 so that they would exactly get two representatives. That doesn't always happen. So it's a messy calculation after this. So the standard quota would be the number in subdivision, state, part of town, how many people are in there, and you're going to divide that by your standard divisor there. So in the case of like North Carolina, there's I think about 7 million people in North Carolina. That number would go up top. And then the standard divisor would be this 731,000. So if there's 7 million people in North Carolina, and you divide by that number up there, your standard quota, SQ, for this example of using this number up here, would be 9.575. So when we talk about a standard quota, it's not coming out as a whole number. If it came out a whole number, we would have no problem with voting. Because it has a partial representation, we don't know if they should get represented by 10 or if they should get represented by just 9. Rounding doesn't always work. Alright, the last thing we need to do is round these things. And for all the methods I'm going to show you, I think rounded quota, we're going to use rounded quotas, which basically is a round down. So that 9.575 would just become 9. So we're going to be doing these calculations over and over again for a few examples. So one of the earliest voting methods was for the House of Representatives was designed by Hamilton. So Hamilton's method, found the standard divisors, standard quotas, and all that fun stuff. So let's go for the standard divisor first. So the population of the entire town is 5,900, and we're voting for 10 seats that are available. And the population for the subdivisions of this town are as follows, region 1 through 5. So to find the standard divisor, we would go and take the entire population and divide it by how many people we're voting for. In this case, 10, which makes the calculation nice. So our standard divisor is 590. So I'll put that up here, 590. Now what we need to do is take the standard divisor and literally divide it into each one of these numbers. So I'm going to do one of them, and then I'll just paste the rest of them in here. So if we were looking at region 5, its quota, unrounded, would equal the 2,000 that live in region 5 divided by the standard divisor, which is 590. And we would get, see here, 2,000 divided by 590. And 3 decimal places is a good place to round it, so this will be 3.390. 3.390. So I'll put that here, 3.390. Alright, the other numbers are these, and they would go for region 1, region 2, region 3, and region 4. And then, of course, region 5 is a 3.390. Alright, then Hamilton said, well, let's just go through and round all of these. Now, when they round, Hamilton at least, and most of them, round down. It's not just a regular old rounding. So this 0.847 rounded down is actually 0. 1.356 is going to give you 1. The 2 is just going to give you the 2. The 2 is going to give you the 2. And the 3 gives you a 3. Then he would add these all up. So this is 6, 8. Total of 8 seats taken care of so far. Well, the problem is we're supposed to have 10 seats taken care of. So that leaves us 2 extra ones. So Hamilton said, well, we got these extra ones. Let's give them to the ones that deserve it. Well, the one that deserves it right away is 0. So, people should have some kind of representation. So zeros automatically took one of those extra ones. And then out of the rest, you would look for the highest decimal value. Well, we already took care of the zero's highest decimal value. So the next highest decimal value would be the 390 down here. So he would get an extra representation. So you would add your rounded number, the extra number, then the apportionment, I love that word, apportionment, would get 1 here, 1 representative for region 2, 2 representatives for 3, 2 representatives for 4, and 4 representatives for 5. And when we add them up, 2, 4, 6 plus 4 is 10. it gives us the 10 seats that we were looking for. So this is each region's representation. Region 5, of course, gets the most because it's the most populous. There are problems with Hamilton's method, one of them being if you increase the number of seats, it is possible that one of the regions actually loses a seat, which is really strange. Also, if you change the population, if it goes up, you also have that possibility of losing a seat because of these rounded numbers. So that would be Hamilton's method.